You might recognize this formula from class, and this is actually three of the same formulas. B and C are two sides next to each other with the sign of angle A, which is in between these two sides. Over here, A and C are another two sides next to each other, and B is the angle in between. And then finally over here, A and B are another pair of sides next to each other, and C is the angle in between. So all three of these expressions here are equivalent ways of finding the area of this triangle. These are all the area of the triangle formula, because remember, to find the area of a triangle, you just need any two sides next to each other and the sign of the angle in between. It doesn't specifically matter which of the two sides those are. So what I'm going to do is I'm just going to start over here on the left, and I'm going to just divide everything here by 1/2 ABC. And I'm going to do the same thing over here because this is an equation. So if I do something to one side, I do have to do it to all of the pieces to keep it equal and balanced. Now, we have 1/2 in the top and the bottom, so they cancel out. We have B in the top and the bottom, so they cancel out. And we have C in the top and the bottom, so they cancel out. So what we're left here is sine of angle A over side A. Over here, the 1/2s once again cancel out. The A's cancel out, and the C's cancel out. So what we're left with here is sine of angle B over side B. And then finally here, the 1/2s cancel out, the A's and the B's cancel out. So we're left with sine of angle C over side C. This is the law of sines, and that's what we're going to be talking about in this video. The law of sines is a really useful way to find missing sides and angles of triangles, especially when you don't have right triangles. Because when you have right triangles, you can find sides and angles using trig ratios. But if your triangle is not a right triangle, you can't just use a regular trig ratio. So the law of sines, I'm going to write it here, law of sines can be used with any kind of triangle. And what it means is you're going to put the sine of an angle over the side opposite from that angle. It doesn't matter which of the angles that you use, and you only need two. Sine of the angle over the side opposite from it. The reciprocals are also true. So we can also write this as side over the sine of the angles, and it's exactly the same thing. But in this video, you'll see me using the top way, sine of the angle over the side opposite from it. Let's see how this is used in some practice questions. So over here, we're going to find side Q. And we don't have a right triangle, so I can't just use trig. But what I notice is I have a side, and I have the angle across from it. And the side I'm finding, I have the angle across from it. So this would be a great time to use law of sines. Sine of an angle over the side opposite from it equals to sine of another angle over the side opposite from it. So here, I'll use the 50-degree angle as one of my angles, and Q, the side I'm finding, is the side opposite from it. And I'll use the 30-degree angle as my other angle because I already know the side across from it is 10. And from here, I'm solving for a missing side, so I can cross multiply my proportion. 10 sine 50 is equal to Q sine 30. My goal is to get Q by itself, so I'm going to divide both sides by sine of 30 degrees in order to isolate the Q. I'm going to get my calculator and I'm going to type in. Your best option is to use the fraction button. So that way you don't get confused with parentheses and you can put what you need to in the numerator and what you need to in the denominator. Alpha, the green button, y equals, enter, is the fraction button. So once again, alpha, y equals, enter. And I'm going to round to the nearest tenth. I got that side Q is approximately 15.3 units, approximately 15.3. You type in your calculator, you should get the same thing. So I'm going to put that here, approximately 15.3. Oh, that point looks terrible. Let me erase that and do that again. 15.3. Okay, let's try out the next one. So for the next one, once again, I don't have a right triangle. The trig ratios are not going to work. And what we want to do is find the measurement of angle K. So I'm looking for this angle. And guess what? Luckily, I have the side across from it. And look, I have another angle with the side across from it. So law of sines is going to be a good option here. Sine of one angle over the side across from it equals to sine of another angle over the side across from it. I'm going to plug in. So one of my angles I'm going to use is angle K because it's the angle I'm looking for over the side opposite from it. The other angle I'm going to use is the 45-degree angle because I already have the side opposite from it. From here, I'm going to cross multiply my proportion. I have 8 sine of angle K equals to 10 sine 45. Now my goal is to isolate angle K. So I'm going to start off by dividing both sides by 8. So sine of angle K is equal to 10 sine of 45 over 8. But now look how the K is trapped inside of the sine function. We are ultimately solving for an angle here. So in order to undo the sine function, we do have to use inverse sine. So I'm going to take inverse sine of our sine ratio, which is 10 sine of 45 over 8. And that should give me approximately what the angle K is that made that ratio in the first place. Highly recommend using the fraction button. So I'm going to hit second sine. Now I have inverse sine on my calculator. I'm going to hit alpha y equals enter to get my fraction button. On the top, I'm going to type in 10 sine 45. And on the denominator, I'm going to type in 8. And when I hit enter, if we round to the nearest tenth again, angle K is approximately 62.1 degrees. So angle K is approximately 62.1 degrees. Let's do a couple of more practice questions using the law of sines. Here we have triangle DAT. So I'm going to draw it. DAT. Angle D is 27 degrees. Angle A is 105 degrees. And side T, opposite from angle T, is 21. Find D. So I'm finding the side opposite from angle D. So I'm finding D to the nearest integer. So I'm finding D, and I already have the angle across from it, so that's good. The other side I have information about is 21, but I need the angle across from it, which I don't have. But luckily, I have the two other angles of the triangle, 105 and 27. And if I add them together, that makes 132. If I subtract that from 180, because all angles of any triangle add to 180, 180 minus 132 is 48 degrees. So now I can set up sine of one angle. I'm going to use the 27-degree angle first over the side across from it. And I want to solve for side D. So I definitely want that to be in my proportion. The other angle I'm going to use is the 48-degree angle. And that's because I already have the side across from it. From here, we're going to cross multiply 21 sine 27 equals to d sine 48. Remember, we're solving for d, so we want to isolate the d. So let's divide both sides by sine of 48. And this question does say to round to the nearest integer, which is whole number. So on my calculator, I'm going to type in 21 sine 27 divided by sine of 48. And to the nearest whole number, that is approximately 13. So D is approximately 13. Let's check out this one. So we have triangle ABC, where A is 12. Sine of angle A is 1/3, so be careful. Angle A is not 1/3. This is the whole sine of angle A. And sine of angle C is 1/4. So be careful. Angle C is not 1/4. It's sine of angle C that's 1/4. Find C. So let's set this up. Sine of one angle over the side across from it equals to sine of another angle over the side across from it. So we already have sine of this angle, which is 1/3, over the side across from it is 12. And we already have sine of another angle. We have sine of this angle is 1/4 over the side across from it, which is what we're looking for here. So we can cross multiply our proportion and we can solve. So I have 1/3 C is equal to 12 times 1/4 is 3, because that's 12 divided by 4, which is 3. And then to get C by itself, I can multiply both sides by 3, because that's the reciprocal of 1/3. It cancels 1/3 out. So I have C is equal to 9. So the side that we're looking for is 9. This time we have right triangle ABC, and it tells us that angle C is a right angle. So we do have a right triangle here. Angle A is 56 degrees, and BC is 8.7. We need to find AB to the nearest tenth. So here we have options. You can use a regular trig ratio. Here you can use sine, opposite over hypotenuse. Or you can use the law of sines. And since this is on a video of law of sines, I'm going to use law of sines. Actually, I'll use both to show you that it's the same thing. So first I'm going to use a regular sine ratio. So sine of 56 is equal to opposite over hypotenuse. I'm going to put this over 1 and cross multiply. We have x sine 56 is equal to 8.7. To get the x by itself, I'm going to divide both sides by sine of 56. That cancels out. I'm going to type this into my calculator. Alpha y equals enter for the fraction button. And that's 8.7 for the numerator divided by sine of 56. And that's approximately 10.5 to the nearest tenth. Now let's do it with law of sines. So I have sine of the 56-degree angle over 8.7 equals to sine of the 90-degree angle over x. Cross multiply. X sine 56 equals to 8.7 sine of 90. Divide both by sine of 56. And on my calculator, 8.7 sine of 90 divided by sine of 56 is the same thing. It is approximately 10.5. You might be wondering, How did these evaluate to the same thing when we had a different result from cross multiplication? Here when we cross multiplied, we just had 8.7. But here when we cross multiplied, we had 8.7 sine of 90. Well, if you type sine of 90 into your calculator, that's just 1. And that's why when we're using a trig ratio, you can't focus on the 90-degree angle because sine of 90 is just 1. But here, it didn't impact in the law of sines because since sine of 90 is 1, it just made it evaluate to the same thing as our ratio. So basically, when you're using law of sines, you don't have to worry about which angles you're using. You can even use the 90-degree angle and it will be fine. So here's two ways: regular trig ratio, law of sines, it evaluates to the same value. This is the last one that we're going to do in this video on law of sines, and we need to find angle S. So that's this angle here. So I want to make sure, and this is not the right triangle, so I have to use law of sines. I want to make sure that angle S is in here. I need the side across from it, but I don't have it. So I'm not going to be able to put angle S here because I don't have the side across from it. What I can find is I can find angle T first, because I do have the side across from angle T, and I also have this angle and the side opposite from it. So I'm going to use sine of angle T over the side opposite from it, which is 10, equals to sine of 105 over the side opposite from it, which is 12. I'm going to cross multiply 12 sine of angle T equals to 10 sine 105. Remember, we want to get the t by itself, so we're going to divide both sides by 12. So now we have sine of angle t equals to 10 sine 105 over 12. To find what angle t is, we're going to have to use inverse sine of our sine ratio. I'm going to type this into the calculator. I'm going to use second sine, and then I'm going to get my fraction button. I'm going to type in 10 sine 105 over 12. And that is approximately, I'm going to leave a decimal place for now, 53.6. So angle T is approximately 53.6 degrees. I'm going to add that with the 105 degrees we already have inside the triangle. And I got about 158.6 degrees in total. And then I'm going to subtract that from 180 to find what the last angle of the triangle should be. And now I'm going to round to the nearest degree. And I found that angle S should be approximately 21 degrees.